Hello, welcome to this video on power series. We're going to look at a specific question. It might take the whole video just to answer this one question. It's a two-part question. We'd like to represent the function below as a power series, and we'd like to take it a step further and find the interval of convergence. All right. So what we have in previous videos developed is a set of 4 different functions that we know the power series expansion for. This particular function looks a lot like one of them, so we isolate that one and we make it our launching point. You see, our first job will be to algebraically manipulate our function to look like and behave like the given function that's in the box there, number 3 on our list of series that we should know the functions that we should know the power series expansion for. Okay, all right, great. So we're looking at natural log of 3 plus x squared, and the series that we know is for natural log of 1 plus x. Our first job to make the 3 a 1 by factoring out the 3. So we factor out the 3. It's still inside of a log. Okay. Now, the cost of that is that there's no 3 factor on the x squared. So by factoring out the 3, we put a 3 underneath. Now what do we do? Well, the log of a product is the sum of the logs. You can break it up. Let's use that property. It'll be the natural log of 3 plus the natural log of 1 plus x squared quantity. Over 3. 1 plus x squared over 3. All right, great. We have our constant term, and then we're going to focus on the natural log of 1 plus x squared over 3 and use the series that's in the box above, because the only difference now is that in place of x, I have x squared over 3. So now I'm just going to replace every x by x squared over 3 in the individual terms and in the summation. Don't forget that first term is there as well, though, natural log of 3. We're doing great. And so the last bit of work to do is just to simplify it. The hard work is done. X squared over 3 quantity squared, simplify that, cube and the fourth. Let's simplify those guys. All right. We'll have x to the 4th over 9, then over 2. So x to the 4th over 81. No, wait, 81? 18, sorry. 81 is the next guy. X to the 6th on top of 27, then 27 times 3. That's your 81. Looks like I don't have the 4th guy there. But it would be x to the 8th on top of 81 times 4. 324? Yeah, alternating in sign. And so in the summation, we'd have to take the x to the officially 2n plus 2. It's 2 times the quantity of n plus 1. And let's take the 3 to the n plus 1. And we have ourselves the power series. We've represented the function below as a power series. Half the job is done. Great. We want to know, though, what x's will make this convergent. That's the interval of convergence, so we have to find that. Best way to do that is by the ratio test. If you can actually have it as all terms being raised to the n, then root test would be your go-to. But ratio test is our go-to here. Remember the ratio test now. Officially what you're doing is dividing a sub n plus 1 by a sub n. But a sub n has 4 different terms to it. And a sub n plus 1 also has 4 terms to it. So we don't want to write 4 terms on top of 4 terms, flip the bottom 4 terms, juggle them up. So here's my shortcut to being able to execute this limit is by first replacing all the n's with n plus 1s. Exactly where they're at in their own fraction. And then underneath, putting the original terms that match up, because they get reciprocated. I think that might be the opposite of the color scheme that I chose before. That's okay. All right, and what do we do next? Break apart these exponents and get some canceling done. So we cancel the -1 to the ends. We cancel the 3 to the ends. We cancel the x to the 2 ends. Be careful with this, this x term. It was x to the 2n plus 2. Your job was to put an n plus 1 in its place. But that 2 gets distributed, so it'd be 2n plus 2 plus another 2. That's how we got the 2n plus 4. Yeah, so what about the individual limits? The first limit, -1. Second limit, 1/3. Third limit, 1. Fourth limit, x squared. You're inside absolute value bars, so the -1 doesn't matter. But our job then from the ratio test, if we want convergence, then this limit has to be less than 1. These are the x's that would give you convergence, the solutions to this inequality. How do you handle absolute value inequalities? Well, if you have a product of terms, you could break apart and give the absolute value to each part of the product. So we can have a -1/3 in its own absolute value come out as a 1/3. And then x squared still be inside the absolute value. Multiply by 3. And then the square can actually come outside. If you have, you can take x squared and make it x times x and do absolute value of each one. And it actually is then the absolute value quantity squared. And then you could take a square root. It's a legal action with an inequality. And so the absolute value of x needs to be less than square root of 3. Meaning that x needs to be in between -√3 and √3. We're good. Great work. Are we done? Not quite. Almost. We got to check these endpoints. Is it possible that we can get convergence at √3? Or convergence at -√3? Let's go to the next slide for that. So at -√3, you replace, remember the series now, replace the x with -√3. Have it color coded here. All the other terms are exactly the same. Now, the algebra here with the -√3 raised to the 2n plus 2, what you can do is go back to the broken up version, 2 times the quantity of n plus 1. That's the simplified version of that guy. And so you can make it -√3 to the 2, and then that whole thing is to the n plus 1. Why would you want to do that? Why is that beneficial to you? Well, the -√3 squared is just a 3. And then that's to the n plus 1. What's going to happen there? Cancellation. This is the alternating harmonic shifted. It's convergent by the alternating series test. Without the alternating, it'd be divergent. It's weak. It's conditional convergence. All right, what about √3? How are we doing on time? We're doing good. Okay. How about √3? Same action, same result. -√3 squared, the same thing as √3 squared. You'll still get a 3. Still raised to the n plus 1. Still going to cancel with the other guy. Still going to converge. So you are done. Convergence on the endpoints. You started off with this function. You were tasked with the 2-part question of finding the power series representation and finding the interval of convergence. You did it. Great work. That was a lot. Well, thanks for watching. My name is Nakia Rimmer. I'm here to help you through this journey with these series of videos in Calc 2. We will answer any questions that you'd like. Please ask them in the comments down below or reach out to me. And be sure to watch the next video as we dive a little bit deeper into the pool. All right. Thanks for watching. I'll see you in the next video.